So the first thing we have to do is find the values of a and b. So if I compare 7 is the coefficient of sine x, and for sine x here we've got 2a and negative b. So 2a minus b gives me 7. And if I compare, do the same thing, but now I'm looking at 11 for the coefficient of cos x. So I've got a 2b there and I've got an a. So a plus 2b gives me 11 there. So if I just double the top, so that'll be 4a, that'll be a negative 2b, and this will be a 14, and then just add them together, you'll get a 5a, the b's will cancel, you get a 25, so that a is 5. If I pop the a back into one of those, so my 5 plus 2b equals 11, so 2b equals 6, so b equals 3. So I'm just going to put it up here, a is 5 and b is 3. There. Alright, so how can we use that? Well, let's have a little look here. So if I put that a and that b in this side over here, I am going to have 5, 2 sine x plus cos x, plus 3, 2 cos x minus sine x there. And that is going to be, we're going to kind of replace the top of that with this one. Now if you think about it, I'm dividing by 2 sine x cos x, cos x. So if I just separate that into two fractions, the first one will just be 5. So it's really just 5 plus, so that's really the integral of 5 plus 3 lots of 2 cos x minus sine x on 2 sine x plus cos x dx. So this is what we're finding between 0 and, I think that's a pi on 2. So clearly, if I just take the 5, I would integrate that and get a 5x. And if you think about 5x between pi on 2 and 0, if I sub pi on 2 in, I'll get 5 pi on 2. If I sub 0 in, I'll get 0. So I already know the first bit of that integral, which I'm not going to bother writing down, is 5 pi on 2. And then, if I put the 3 outside of 0 to pi on 2, I've just got 2 cos x minus sine x on 2 sine x plus cos x dx. Now, if you didn't have, I mean, hopefully you could see that that looks like a log, but look at what we're trying to prove. We've already got the 5 pi on 2 part, the first term, and it's a log. So we know that we get a log when the derivative of the bottom of the bottom is at the top. So if I look at the bottom, which is 2 sine x, and I wrote the wrong one, 2 sine x plus cos x, and if I differentiate that, look what you get, 2 cos x minus sine x, which is the top. So we've got a log straight away there. So we've got a 3 outside of, but we're going to get a log of the bottom, which is 2 sine x plus cos x, and that will be between that and that. So I'm just kind of working on the side as well as here, so I'll put the 3 there. So when I sub pi on 2 in there, remember your sine x curve, you'll get a 1, whereas your cos x curve, you'll get a 0. So I'm going to get a 2 plus a 0, so that'll be a log 2. And then when I put a 0 in, cos x will be 1 and sine x will be 0, so I'm just going to get log 1. But log 2 minus log 1 is 0, so log 2 minus log 1 is just log 2. So I'm just getting 3 log 2 there. But if I want to put a half out the front, I've got to times it by 2, so I'm going to get a 6 log 2, which is our answer.